Alright, so we're going to go ahead and do study guide number 22. Study guide 22. First problem. It's same as we've been doing here. We have x times x cubed to the second power. Now that x is x to the first. So we go inside and we simplify that first. Power times a power. Multiplying powers of the same base, we add those exponents. 1 plus 3 is 2. Now, power next to a power, we multiply those exponents. So this simplifies to x to the 8th. So we're going to find all the expressions that are equivalent to x to the 8th. Expression number 1 has x cubed times x squared. That's multiplying powers with the same base. So what we do there, we copy the base one time and add all those exponents. 6 plus 2 is 8. So that's the same. Exponent number 2. Exponent number 2, we have power divided by power with the same base. When they're the same base, you can copy the base and subtract. So if I go, that top one is 13. 13. So I have x to the top minus bottom. Okay? 13 take away 5 is 8. So exponent number 2 works. Expression number 3. Expression number 3, we have x to the 11th times x to the negative 7th divided by x. So we're going to do, just like we did up here, we're going to do the product part first. So I copy the base and add these two. So expression 3, that's an 11 there. So when I add those two, those are opposite teams. When they're opposite teams, I subtract. So I wouldn't get a 13 from that. I would get a 9. Now, there's more positives than negatives, so that's positive 9. 11 plus negative 2 is positive 9, or in other words, 11 take away 2. Now I do the division part. I copy the base and subtract these two exponents, and I see that expression 3 is also the same. And expression 4, they already have x to the 4th simplified for us, so that's not the same. Don't pick that one. So our answer for problem number 1 was expressions 1, 2, and 3. Alright, problem number 2 from the study guide, number 2. About how many times more is this number than this number? About how many times more is division? So, how many times more is this than this? I'm going to put the bigger one on top, but they say the secret word, which is about, so I get a round. So that's about 6 times 10 to the 21st over, that's about 3 times 10 to the 18th. Now when I divide these two, 6 divided by 3 is 2. Now if it was the other way around, that would be 0.5, so be careful. So go in and out. Times 10 to these, just like we did over here. Subtract those exponents. 21 take away 18. 21 take away 18. That's a difference of 3, so it's about 2 times 10 to the 3rd power bigger. Or in other words, since they didn't have that in scientific notation in our answers, that's 2 with 3 zeros, or 2,000 times bigger. About. Bless you. Alright. So, number 3. So we're going to find the value for k that makes the equation true. So for number 3 on our study guide, we're going to solve this equation. Negative 4 times some number minus 9 plus 7 times the same number plus 7 equals 94. Okay? So they say, what is k that makes this true? In other words, figure out k. We're going to combine, well, we always simplify both sides of our equation first, right? So we distribute and combine like terms. We can't distribute, so we just combine like terms. If I have negative 3 and positive 7, that's a difference of 3k, because there's more positives than negatives. Over here, opposite teams mean subtract. There are more negatives. That's why it's a negative sign. Now I isolate the variable, do the inverse operations at this point, and then divide by 3. And I get k is 96 divided by 3 is going to be, what, 32? So 32 is the number that makes this true. Next problem, number 4. Number 4, we're going to find the value for x that makes the equation true. We have another equation that we're solving. Again, we simplify both sides first, which means we distribute and combine like terms, and then we start to isolate the variable. So to distribute, if I'm going to multiply by 1/4, that's the same as dividing by the number 4. So 1/4 of 4 is 1, so I got x plus 1/4 of 40 is 10 because 4 times 10 is 40. So I distribute, and now I combine like terms. I have 1x and 3 more x's. That makes 4 x's. Sorry. Okay, so then I go ahead and subtract 10 from both sides. Okay, so we combined our like terms there. Got this. Subtracted 10 from both sides. Now I get 4x equals, now these are on the same team, they're both negative, so we add those together. Now I divide by 4. If I divide a negative by a positive, my answer is negative, so it should be negative 8. So number 4, answer for number 4 in the study guide is negative 8. Okay, next problem. Alright, number 5 on our study guide. We had to figure out which of these equations have infinitely many solutions. So we're going to simplify each of those. For number 5, equation number 1. Equation number 1 has 8x plus 10 equals the opposite of 8x minus 10. So to simplify both sides, we just distribute and combine like terms. I distribute negative. The opposite of 8x is negative 8x, and the opposite of negative 10 is positive 10, and now those parentheses go away. And I look at this. If these were the same, and I tried to isolate the variable, they're going to cross out. So that would be a special case. But since they're different, this will have one solution. There will be an answer for this because these x's are different. I can stop right there. Okay? This has one solution. This cannot be infinitely many solutions. So I don't pick equation 1. So equation 2. Equation 2. I'm going to solve this equation. 9 times 2x plus 1 minus 5 equals 19x minus negative 4 plus x. Okay? So, let's distribute first and then combine like terms. 9 times 2x is 18x. 9 times 1 is 9. Over here, that 19x is not next to that, so I distribute the negative, not the 19x. Negative times negative, or the opposite of negative 4, is positive 4. Negative times positive, or the opposite of positive x, is negative x. Now I'm going to combine like terms. I have 18x. These are like terms because they're numbers without variables, so they're constants. Constants are like terms. Over here, I got 19x take away in x. 19x take away in x is 18x plus 4. These are the exact same thing on both sides. So it doesn't matter what number I pick, everything's going to be an answer if they're the same exact thing. This is infinitely many solutions. So we're going to pick equation 2 for sure. Equation 3, we have negative 1 plus 2x minus 1 equals negative x plus 3 times x minus 2. I'll make sure I copy that right. Okay, so we're going to simplify both sides to see how many solutions it has. Okay, I only have 2 x's, but I have 2 negative constants, negative 1 and negative 1 is negative 2. Over here I have to distribute before I try to add anything. 3 times x is 3x. 3 times negative 2 is negative 6. Left side simplified already. Oh my goodness, sorry. Okay, let me back up here. I combine these two to get negative 2. Over here I distributed the 3. 3 times x to get 3x. 3 times negative 2 is negative 6. Okay. Now this part's already simplified. I'm going to go over here, combine like terms for these two right here. And I see that we have the same coefficient but different constants. Okay, so when I go to solve this, this will have no solution. There are no answers. This will not work. So we don't pick that because we're looking for infinitely many. Alright, so now we're on equation 4. So equation 4, we have 10 take away 7, 10 minus 7 times 2x minus 1 equals x minus 12x plus 17 minus 3x. So we're going to simplify both sides of this equation. So here I'm going to distribute a negative 7. Don't forget that minus sign. So negative 7 times positive is negative 14x. Negative times negative is positive. Over here, nothing to distribute, so we'll combine like terms. I have negative 12x and 3 more negative x's, which is negative 15x, and 1 positive x. So negative 15x and 1 positive is negative 14x plus 17. I have negative 14x plus 17 on this side. When I combine like terms, I have the exact same thing on both sides. That's infinitely many solutions. Alright, so my answer for this were equations 2 and 4. Problem number 5, equations 2 and 4. Alright, problem number 6. So problem number 6, we have which ordered pairs below are solutions for this. So they give us a function, a linear function, and they say which one are ordered pairs. So ordered pair number 1 was negative 4, negative 1. So I just plug it in. I put the negative 4 here and the negative 1 here. Okay, so negative 1 equals 2 times negative 4 plus 3. So I just plug those in. And I see here that this is not going to equal that. So forget that. That's not a solution for that. Okay, let's check number 2 now. Number 2, I plug in 0, 3. So I plug in, this is my x and this is my y. I put the 3 here. I have 2 times 0. That's true. That's the same thing. So that works. That's a solution. So point 2 works. Now point 3. 411. Plug it into the equation. So there's my y. There's my x. 8 plus 11 checks out. That's one of the solutions. And number 4, we test it. We have y equals 2x plus 3. And the equation is 3, 9. So when I plug that in, my y is 9. There's my 2. Plug in the 3. And I simplify, first multiply, right? Then add, and I see that checks out too. So for this line here, these 3 points are on that line, so the solutions for those are 2, 3, 4. Alright, number 7. Moving along, trying to get through it quickly here. Number 7. Which relation located under the graph has a greater rate of change? So if you look at this graph here, let me zoom in. We're going to pick 2 points on the lattices. That means 2 points where the lines intersect. Look, there's 2 right there. Okay? So I go rise over run. I go up 1, and I go over 1. My slope is 1. Now I got to figure out which of these 4 right here have a number that's greater than 1, the absolute value. For if it was negative 2, it's still steeper, right? Negative 2 is a smaller number, but it's a steeper slope. So we look at the absolute value. So let's do that. So for number 7, the first relation was a table. And they give us this table here. And what we're going to do is take any 2 points we want. But I see that 0, 0. If it's 0, 0, this is proportional. So I can just use 1 point. So if I take the y and I put the y over the x, I already have slope. So my slope for relation 1, the slope has to be, put y over x, 1/10. Right? There's another point, 220, but 220 is the same as 1 over 10, 2/20. Okay? So relation 2 now. Relation 2. Relation 2 gives us a table. I'm going to pick any 2 points I want. I'll pick the first one. Some of you might want to avoid negatives. And the second one. Okay? Alright, so I go y minus y over x minus x. And I see I got a slope of 2. This one is a greater slope than a slope of 1. So that's one of our answers. Relation 3. Relation 3 gives us an equation. It's in slope-intercept form because the y is isolated. The slope is in front of x. 5/4. 5/4 is a number that's bigger than 1, right? Because 4/4 is 1, 5/4 is more. So, relation 3 has a greater slope than the equation. And the last one gives us 2 sets of coordinates. -4, 16, and 3, -12. So again, to get my slope, I would do y minus y over x minus x. Okay, so I'm going to take, I'm going to take 16, take away -12. Be careful, when you're subtracting a negative, make sure you put the 2 minus signs, okay? That's where people get this wrong. And then do the x's. So I go x minus x, right? If I go top minus bottom, I have to go top minus bottom there as well. Add the opposite, I get 28. Add the opposite, I get negative 7. That's the slope of negative 4. The absolute value is more than 1, so that's another answer. So here, all the relations that had a slope greater than the graph are relations 2, 3, and 4. Okay, problem number 8. We have to select a statement that correctly describes the solution to the system here. So for number 8, they give us a system, two equations. We have negative 36 times x minus 3y equals negative 3, and y equals negative 12x plus 1. If I'm going to figure out where these two lines intersect, then all I'll do is I'll take this, since this is isolated already, and plug it in into the other one where that letter is. So I have negative 36x minus 3. I'm writing this again right here. But instead of putting y, I'm putting this in parentheses. Now, just like before, distribute, combine like terms. Distribute, negative times negative is positive. Negative times positive is negative. Combine like terms. Okay, so what happened here was that our variables crossed out, and we got something that's true. If this said negative 3 equals 4, that's not true. So if this is true, then that means these are actually the same line. This is infinitely many solutions. Infinitely many solutions, okay? And that was the answer for number 8 on our study guide. Number 9. One equation is x minus 2y equals negative 3. We have to figure out which of these creates also infinitely many. So again, we're trying to figure out which one's the same. So what we'll do then is we'll use the multiplication property of equality and just try to figure out what factor multiplied all these to these. But the trick is this. A, the order was changed on you. So you see the y got moved here and the x got moved here. Don't let me fool you with that. So I see here this is negative y and this is positive y. That means I multiplied by negative 1. If this is positive x and that's negative x, I multiplied by negative 1. If this is negative 3, if I multiply by negative 1, that's supposed to be 3. This is not the same line as this. There are not infinitely many solutions between these two. So let's check the next one. 2y minus x equals negative 3. So I can see we changed the sign for y, changed the sign for x, did not change the sign for the constant. That's not infinitely many solutions. Next one, 2y minus x equals negative 3. Change the sign for y, change the sign for x. Whoops. Oh, sorry. This is C. That's incorrect. For B, I wrote it incorrectly. Sorry about that. For B, that was actually positive. Just trying to go real faster to get through all of them. That was positive. So that was changed, and that was changed. These are all multiplied by the same number, which is negative 1. So there's our answer. The answer was B. Okay, so D won't work because let's see why. Let's see why D won't work. Okay, so here my y's are multiplied by positive 2. This was multiplied by positive 2, and the negative 3 wasn't multiplied at all. That's why D doesn't work. So the answer for this one was B. All right, number 10. Moving right along. Number 10. Whoops. Number 10. It says Mondo's CrossFit Gym charges $125 per month, no initiation. That looks like this, $125 times every month. Ethan's Powerhouse charges $100 per month. That's 100 times each month, plus a one-time or initiation fee or a y-intercept of $350. When are they the same? So write them equal to each other, and we'll figure out when, or number of x, number of months, they're the same or equal. So solve for x, subtract 100x from both sides, you get 25x equals 350. Divide both sides by 25, and x equals, well, what did I do incorrectly here? Nothing. Okay, so I go in and out, divide these two. 25 goes into that one time, and that goes in 4 times, so it's after 14 months. Let's double check that answer here. Always check your answer when you're done. Don't wait till later. Okay, check it right away. All right, so number 10. Now let's do number 11. The following are examples of relations. Which are functions? Well, if you see y squared, it's not a function. Don't pick one. We're looking to see if our x's repeat, right? So there's a 5. Oh, there's another 5. That's not a function. Our x's can't repeat. Our y's can, not our x's. Relation 3. You see, none of my x's repeat. That's a function. And relation 4. None of my x's should repeat. In other words, if I were to draw a vertical line down any of the graph, it should only hit everything one time. That's a function. Answer 3 and 4 for number 11. Okay, so remember the vertical line test for that. Number 12. Number 12, we're going to write the equation for the linear function. And the nice thing about number 12 is they give these in order. If they give these in order, you can simply see the slope from the table. You don't have to do y minus y over x minus x like we did earlier. So I see that this is going up how many times each time? It looks like it's going up 7 each time. Every single time. That means my slope is 7. Put the slope in front of x. And my y-intercept is, well, if my x is 0, my y-intercept has to be the negative 2. So, done. That's how you do number 12. Okay, so check our answer real quick. Yep. Number 13, we're going to write the equation for this line. I see the y-intercept is 2. That's my b. And let's do rise over run. I go up. Now, since these are counting by ones, be careful. Sometimes they're not counting by ones. But if they're counting by ones, you just count. Up 1. Over 2, it's a positive slope because it's going uphill, not negative slope going downhill, right? So my equation is y equals 1/2 x plus 2. Because there's a plus 2, there's a 1/2. Done. Number 14. Find the missing side. Okay? We have a right triangle here. We go leg squared plus leg squared equals hypotenuse squared. So I go leg squared plus leg squared. Remember, the long side is the one that's got to be by itself, okay? That's the one that's got to be alone. So then all I do here is I multiply this and I multiply this. Okay? Alright, let's just take the time, do it real fast. So multiply these two, I get this. And multiply these two, I get this. And then I'm going to subtract these two. And get the difference. Okay, and the difference, let's see here, 80, okay, okay, I messed up. That is 7225. This one is 7056. Now subtract these two. Okay, and that's a perfect square, and so, oh my goodness, there we go. So I get a difference of 13. That's square root of 13. Okay, so what I did is I did 84 times 84 to get this. 85 times 85 to get this. Subtract these two, okay, to isolate x squared. And I got a difference of 169. Now, to make x squared x, I take the square root of both sides. Take the square root of both sides. That's a perfect square. 13 times 13 is 169. Okay, number 15. Alright, trying to rush through all these. Number 15, we have a right triangle. Okay, and it looks like they gave us both legs and we're missing the hypotenuse. So for number 15, we have 4 squared plus 2.8 squared equals, now this time we don't have that long side, so that's where our letter has to go. You can use an X or a C, whatever you like. 4 times 4 is 16. You're going to do 2.8 times 2.8, and that's 7.84. Okay, now we got to add these two this time. Remember, last time we subtracted. This time we're going to add because they're on the same side to add. Okay, so I got 23.84. Now I have to take the square root of both sides to make this into C, and that's going to be my answer, the square root of 23 and 84/100ths, because they wanted an exact answer. All right, number 16. So we got a right triangle with two different sides. This is one side and this is the other. And they say, what are the two possible lengths? Again, the trick here, we talked about this last time. The trick here is they can both be legs, or the long one can be a hypotenuse and the other one can be a leg. Those are two options. So we set this up like this. We're at 11 plus 110 squared equals c squared. That's one option. And we have to remember that rad 11 squared cancels out. The square root in that cancels out. Add these two together. I get, what's that, 121. Now take the square root of that, and that happens to be a perfect square. So this can be 11 units long. The other one, I have leg squared plus, I'm missing a leg here, leg squared equals hypotenuse squared. So that simplifies to 11. That simplifies to 110. I subtract. Oops. Okay. So borrow from there. Then take the square root of both sides. And b will be the square root of 99. Okay. All right, almost done. 17. So for 17, we have another right triangle problem. So they say find h, they give you the base is 56, and then they want you can use this, which is the same as this, as the hypotenuse. Okay? So we have 65 here, so it's going to look like this for number 17. We're going to have h squared plus 56 squared equals 65 squared, similar to the last two problems. I'm going to let you guys finish that for the sake of time here. Number 18, we have a graph. Okay? We're going to make a right triangle from this graph here. This distance is 1. This distance is 1, 2, 3, 4. So number 18 looks like this. We have 1 squared plus 4 squared equals c squared. You guys are going to finish that. 19, what's the distance between these two? Now this time they don't give us a drawing, so we use a distance formula. We subtract the x's squared plus subtract the y squared to get our answer. So I go x minus x squared plus y minus y squared equals the square root. Simplify that and you got your answer. And number 20, out of time here. Number 20, we're going to translate, okay? We're going to translate 9 to the left. We're going to subtract 9 from our x's. Read the following statement. Now, the triangle is similar and congruent. It's both. The term is similar, not congruent. No, it's congruent if it is a translation. The image is bigger. No, that's only for dilations. So only statement 1 is true. All right, that's it this week.